Burke Parsons Bowlby Corporation, the recognized leader in railroad timber products, introduces a brand new concept in grade crossing design and construction, the BPB unit crossing. This crossing was engineered to specifically address the problems caused by today's heavy traffic loads. Its unique design allows for much faster installation while providing the needed support for the track structure and crossing surface, assuring excellent service life. Advantages to the BPB unit crossing include manufacture in a controlled environment. It provides superior track structure. The panels are easily replaced. Extended service life. It reduces installation time. It can be installed with standard equipment. It's the most cost-effective crossing on the market. Rail and tie plates can be provided. Railroad cars are not required. And the track can be resurfaced with most standard tamping equipment. A prefabricated crossing, which is constructed in a controlled plant environment and designed to hold the ties firmly in the same plane and evenly spaced, built to rigid specifications and standards, it can be replaced rapidly if damage occurs and can be installed with tie plates and rail attached in less than 24 hours. By following the specifications recommended, the Burke Parsons Bowlby unit crossing assures a quality crossing with extended service life. This video is a description of a BPB unit crossing being installed on the Nittany and Bald Eagle Railroad on Lamb Street in Bellefonte, Pennsylvania in July 1988. For your crossing installation to be successful, good advanced planning, site preparation, and coordination with utilities of municipalities are essential. The old crossing was torn out piecemeal since it was not practical to remove intact. After the old crossing is removed, a backhoe removes the foul ballast and mud and contours the new crossing road back to predetermined specifications. The age-old enemy of all railroad crossings is surface and groundwater, and it's necessary that the drainage system functions as designed. 6-inch PVC perforated pipe is temporarily set in the lateral ditches on a bed of ballast and adjusted to assure that all water drains out of the crossing. In this case, the drainage system was designed to flow east and empty into an open ditch approximately 125 feet from the crossing. After the drainage pipes have been adjusted to proper grade, they're removed and a geotextile filler fabric is installed. The fabric is wide enough to cover the entire area. After spreading the fabric on the roadbed, the drainage pipes are placed on top of it at the previous grade, and the fabric is tucked over the pipes and ballast applied. While the ballast is being spread on top of the fabric, a mobile crane is moved into place, and the truck which brought the unit crossing from the BPB plant at Du Bois, Pennsylvania, where it was fabricated, to the site is moved into unloading position. Where physical conditions permit, the unit crossing can be unloaded and placed in the crossing area using a front-end loader and the self-unloading crane on the transport truck. Weight of the crossing without the rail and intermediate panels is approximately 6 tons. The intermediate members of the unit were removed first and set in a predetermined area where they would be out of the way, yet accessible when needed. All of the intermediate timbers have been pre-drilled and pre-assembled at the Du Bois plant to assure a proper fit. All members were numbered and labeled to expedite field installation. A box beam spreader was used to unload the panel. The spreader had a 2-point lift application with a center hitch to minimize any negative deflection. With the panel in position, the 132-pound RE rail was set and connected to the existing trackage. Because there were different sections of rail involved, it was necessary to apply compromise joints. A front end loader was used to place ballast in the crossing. 2-inch by 10-inch by 10 feet treated end boards were nailed to the ends of the ties to prohibit foul material from entering the roadbed. As the ballast was applied, the panel was jacked to approximate grade. Because of the limited space between the panel and the roadway, inverted jack handles were required to operate the high model track jacks. A Canron 16 tool switch tamper with a translating head was used to make the initial and final lifts. The unit crossing is designed to permit the usage of most automatic tamping machines. A locomotive was run over the crossing prior to the final raise. After the final surface, the pre-drilled intermediate and edge timbers were installed as the paving was progressing. Bituminous asphalt material is placed in the crossing approaches, and it was rolled and vibrated for proper compaction. Since the old pavement was sawed at the approaches, a neat edge existed, allowing for a good transition between the new unit crossing and the existing pavement. An advantage here is that the panels can be installed while the paving is taking place. Final dressing up and top course of bituminous asphalt surface was applied to the highway approaches. The finished crossing is now ready for highway traffic. Work remaining consisted of extending drainage pipes to the open ditch at the east end and a general cleanup operation. With the installation of a BPB unit crossing, the Bald Eagle and Nittany Railroad has a highway crossing that will provide them with many years of maintenance-free service. Because of its rigid design, standard construction methods, and proper installation procedures, this crossing will excel all others, including those made of synthetics, and do so at an overall cost savings over an extended service life period.